Hello everyone, good evening. My name is Raman. I'm instructor from the Cognixia team. So welcome to this webinar. Okay, so let me quickly share my screen. Okay, so as you know, this webinar is for DevOps with Kubernetes. So in this webinar, you will get a knowledge that what is DevOps, what is the importance of Docker and Kubernetes in the DevOps. Okay, so that thing we are going to discuss here, right? So now let's get started. So you see this diagram, right? So let us first understand what is DevOps process. Means if you are very new to DevOps, so let me try to explain that. So here you can see that just one moment. Okay. So here you can see I have mentioned. I'm just checking my IDs. So here you can see what is DevOps. DevOps is a process. Okay. So I don't know why that pen is not showing at relevant position. So what I'll do, I will just discard this. I'll copy this image and I will open in MS Paint. That is one of my favorite tools because uh, you can do a lot of things with MS Paint. It is very simple, straightforward tool. Okay, but this lecture is not for MS Paint, right? So now, what is DevOps process? So DevOps is a automation. Now the question is, what is automation? What it will automate? It will automate the SDLC, software development lifecycle. What is software development lifecycle? You might have heard if you belong to IT background, right? So you have heard in your first semester, second semester, right? Or if you are working in some project, so they might be talking about this is our SDLC process. So SDLC is the software development lifecycle. Okay, so what is SDLC? Software development and life cycle. So what is this? Here, if we talk about that you are a developer, okay, so you are a developer here. You are developing some product. So developers are very critical for an organization. Companies are spending a lot of money for to hire the good developer, right? You become a good developer with your experience, with your programming knowledge, right? So developers playing very important role. Most of the thing you can see it is getting automated. Testing is automated, but for that also we need a developer. So development is a process, right, where developers write the code. Developer basically transforming the customer requirement into the actual product, right? So for example, you are going to the you are a customer and you are going to an IT company. Hey, I need a product like Gmail. Okay, so you are giving the requirement that you need something which is like Gmail. So that Gmail, who will convert it? This is your development team. So in the development team, right, there are different types of developers. Those who are writing the code, those who are writing the code for your web application, those who are writing the code for your database, those who are writing the shell scripts, right? So if you are a system administrator, so you are writing the code for you are also a developer in that case. Your designation is system administrator, but under the hood you are working as a developer only because you are writing the script, you are creating the users with the script, right? You are assigning the permissions. So everything is as a development. So development is really very interesting. But for the DevOps engineer, you don't need to learn the development which a real developer is working. If you have a knowledge of Linux, especially when we are talking about the Linux, right? So if you are in the Linux world, if you know how to use the commands, Linux command, how to write the shell script, right, to perform the task as a system administrator, that is more than enough, right? You don't need to learn how to develop a web application, what is HTML, what is Node.js. You don't need as a DevOps engineer. Yes, if you are a DevOps engineer, you are coordinating with the development team, but you are not required to develop the code. You are required to implement the code. Okay, so our as a DevOps engineer, right? So as a DevOps engineer, just guys, just one second only. Just okay. That's some important part. Okay, so now the development is something which is very interesting. And as a DevOps engineer, you are coordinating with that development team. You are not developing the solution. You are developing some scripts with the Kubernetes, Docker, Ansible, right? You are not, but you are not basically writing those web applications, right? So, right. So now the next thing is, okay. So the next thing is that if you are a DevOps engineer, you are dealing with this SDLC. You are basically converting this SDLC into an automation. So in general term, if I say what is SDLC, SDLC is that customer requirement should be converted into the actual product, right? So developer is writing the code and that code will be converting into the end product. That is in a nutshell, uh, we call SDLC. But there are a lot of things in between. It's not like developer has developed the code and given to the production team. No, it's not like that. There is a networking. There is testing. There is infrastructure. There is middleware. So many things are happening in between. So DevOps is basically is an automation process which performs this SDLC. So here you can see there is a developer. Okay. So this developer is writing the code. So when developer is writing the code, that code goes into the version control system. What is version control system? It is mostly used by the development team. So for example, if you are a developer, right, you want to track your code, what changes I have done, what uh, what changes I have done 6 months ago. I want to revert back that changes. Is it possible? Yes, it is possible if you are having the version control system. So version control system is nothing but it is the one which is maintaining the repository for you. Okay, so there is something which is called the local repository and we call it Git, which is a standard tool. Okay, so it's a very commonly asked question. What is the difference between Git and GitHub? What is the difference between Git and GitLab? Right, so Git is a local repository tool. It's a distribution tool. So you are maintaining the repository on your local system so that the commit, the code which you are changing, that code should be committed on your local list. So it should be very fast. And once you make the changes, then you are pushing that code into the remote repository. The remote repository can be anything. Remote repository can be GitHub, GitLab, Azure repos, right? It can be code commit from AWS. So it can be anything, right? So Git and GitHub. So Git is the one which is maintaining the local repository and GitHub is the one which is maintaining the remote repository. Why we need two repositories? So if a new developer joins your project, so that developer will get the latest and greatest code from the GitHub. So that is why a remote repository is required, right? So Git and so GitHub is mostly used by the development team. Okay, but as a DevOps engineer, we should know these commands. The reason is because you are coordinating with the development team, and what they are doing, not development point of view, but for keeping the source code safe. There are different concepts actually we are having here. These concepts are like your mm, branching concept, where you are having different branches for different developers. You have master branch or main branch where your latest code is available. So that is the reason that your you need to keep or maintain your remote repository, and you should know how Git and GitHub works as a DevOps engineer. Even though it is mostly used by the development team, but ultimately when you are creating CI/CD pipeline, you need to connect to the master branch, and you need to keep the you need to keep the code. Not you are not keeping the code. The code is basically kept by the development team into a certain branch. You need to extract that code. Okay, fetch that code. Next is the Maven. Okay, Maven is one of the build automation tool. Okay, so what is build automation tool? See, for example, if you are a developer and you want to give your code for the testing or production, in that case, you are not giving the source code. You are not giving the source code. What you are giving? You are giving the build code, compiled code, executable. So, developer is pushing the code into the development uh, that version control system. Now, after that, it should be automatically pick up that code, and it should automatically build the code. Okay, build the code means compile the code and create the executable. There are different build automation tools are available. See, the importance of DevOps. If you are a DevOps engineer, your demand is very high. Okay, as per industry, DevOps engineer are highly paid. DevOps engineers are the one who are managing the entire infrastructure. So your importance is very high, right? So you need to know what is build automation tool. For example, if you are working with the uh, Java team, right? So most of the open source projects, these are developed in Java. So if you are working as a DevOps engineer and your development team, they are developing the application in Java, so then Maven is the right tool for the build automation. Even though this tool is again mostly used by the development team, but you as a DevOps engineer, you should know the Maven commands. Basic commands, at least you should be aware of that, because you need to use those commands into your CI/CD pipeline. I'm talking about CI/CD again and again, but don't worry, we will discuss about what is CI means, what is CD means. Let me explain this concept first. Then I will explain you what is CI means, what is CD means. Okay. So now this is the build automation tool. So what is the purpose of build automation tool? It takes your code and convert it into the executable. That is the main purpose of the build automation tool. If you are a Python developer, then PyBuilder is the build automation tool. If you are Microsoft developer, MS Build is the build automation tool. If you are Java developer, Maven is the build automation tool, right? So Gradle is another, Ant is another. So there are many tools. Okay. So see, when you are working as a DevOps engineer, you should not restrict yourself to a particular tool. You should know what is the purpose of that tool. For example, if in this course, if you learn Maven and tomorrow you join a project where instead of Maven, MS Build is used, but you know what is Maven doing. So same thing will be done by the MS Build also, but their command will be different. Okay, their command will be different. Other things are different, the but the purpose is same. Okay, so build automation tool is the one which is basically converting your source code into the executable. Now, Docker. Docker is a containerization tool. The time is changed, right? Means I'm working, in the IT industry almost 20 years now. Okay, when I started my career at that time, the applications were very complex. We were writing ASP page. Okay, so ASP page, on single page we are writing every code, but slowly the different layered approaches used. Now these days microservices. So what is microservice? Let me try to explain with one example. For example, you are having a banking application. So we are having a, let's make it 14. You are having a banking application, right? This banking application needs different types of modules, right? For example, it needs internet banking, right? It needs, say an example, withdraw service. It needs something which is called deposit service. It needs something called customer care service. Okay, so these are the different modules. Now, there is a approach which is called the monolithic approach, right? So what is monolithic approach? So monolithic means that monolithic means that everything into a single executable. For example, if you are having the uh, banking application, and everything is a part of that single executable, this internet banking, withdraw, deposit, customer care, right? So this is a part of a single executable. So that is called tightly coupled application. Okay, so that is called tightly coupled application. That is a old approach. So what was the problem in that? So what I'm saying, actually, you are having a single application, and this is your banking application, and everything is into this single application, like your internet banking, your withdraw service, right? Your deposit service, right? And say customer care. Okay. So everything is into this is called monolithic application. Linux kernel is monolithic. Okay. So you just check that topic. Kernel in an operating system. Linux is having a monolithic approach. So everything is into a single kernel, single executable. So this is an old approach. The new approach is that I'm developing this web application, and I need that this internet banking, I need withdraw service, I need deposit service, I need customer care service, right? And all these are basically linked to this banking application. Right. So this is a microservice approach. What is this? Microservice approach. So what is microservice? As the name suggests, right? In the name, you can see microservice. So what is microservice? It is very small application. So very small means its size is less. It is not like that. It is something like that. When it execute, it consumes very less resources, hardware resources. Maybe it is out of 100% of memory, it is consuming 1% of memory, or maybe 0.1%. Okay, I don't know. Means depends upon what type of microservice you have created. So this is creating microservices development job, and our job as a DevOps engineer is to implement it, right? So this is the internet banking, right? This is withdraw banking, withdraw. This is deposit. This is customer care. So all are basically developed separately, and these are getting invoked. So what we are doing, we are invoking the services. Okay. So we are invoking the services. So customer care service. So that customer care service, if you want to call, you are invoking that service. Okay. But this is separately developed, and these are separately deployed as well. So these are deployed in the form of containers. If you are following the DevOps approach. If you are not following DevOps approach, you can deploy directly on a web server. But we are following the DevOps approach. So these all are containers. So this is container, this is container, right? This is container. All are basically running as a container. Right? These are, you can say, deployed as a container. Container is a deployment unit. It's a standard deployment unit in the DevOps. For deploying this, containers, you need something called image. So in our course, we are going to discuss Docker. So we are going to create something called Docker image. Okay. So what is Docker image? Docker image is the one you can compare with your operating system image, right? Like your operating system image, which is ISO file. When you install your operating system, you need that file, right? Similar way, when you run your container, you need a Docker image. In the Docker image, it will have the application build code. Okay, it will have everything, whatever is required for the deployment. There is a very common scenario or very common problem, you can say, that so there is a very common problem that if something is working on the development machine, but it is not working in the production or test environment. So developers say, hey, come, see here. See, it is working. My code is working on my laptop. So production team says, we don't care that right. So we don't care. It is running on your local system. We are worried about the production. It is not working in the production. So if you are following the DevOps approach, what will be the solution? Okay. So your code should be executed on all the environment, whether it is production, whether it is, development, whether it is whatever environment it is, right? So the solution is you need to go with the Docker image. So if you build a Docker image, then if it is working on one environment, it will be definitely be working on other environment also. Okay. So that is the purpose of the Docker image. So all these containers are running with this Docker image. Unique Docker means they will have different Docker image. For withdraw, there will be a different Docker image. For internet banking, so microservices are deployed these days by using containers. Okay. Docker is one of the very, you can say, demanding. It's open source, and it is well accepted by the industry, right? So after build, you are creating the Docker container, okay, with the Docker image. Then there is something called testing. So here, what I'm doing it testing. So there are two types of testing. One testing is unit testing, which is done by the developer. So developer is doing the unit testing, and it's basically validated on the build level also. What is unit testing? For example, you are a developer. You want to give your code to the testing team. So the testing team, they need to validate the code which you have written. It is as per one second. Okay. So whether it is working as per the requirement or not, right? So then we are using the unit. Then they are doing the testing. But before giving to the testing team, you want to make sure that it is working. So for that, you are doing it. Means you means as a developer, what you are doing? You are doing a unit testing. So unit testing uh, is a process which is basically done by the development team to validate whatever the code they have written, it is working as per the expectation. There are different unit testing frameworks are available, right? So we are having frameworks like JUnit, Jupyter for Java-based application. We have PyTest, unit testing in Python. We are having NUnit into the, we are having NUnit in .NET, right? So depends upon which programming language you are using. According to that, there are different types of unit testing frameworks are available. So when you are doing a testing, so this is a integration testing. What is this? Integration testing. What is integration testing? In the integration testing, tester is not testing only your code. For example, you are having a team, you are developing something which is the Gmail or Google Apps, right? So you are working on Gmail, but someone is working on the Google blog, right? So in that case, your Google blog uh, is working with Gmail or not. That will be the job of the integration testing, right? So integration testing is done by the testing team. Now that time is gone. If you are a manual tester, you are doing testing manually. Now this is the time to change, right? You need to switch to automation testing like Selenium. So this is the Selenium logo actually. So Selenium, right? So Selenium is a test automation tool for your web application, right? So for example, your testing team, they want to test your code. What they will do, they will write a script. So Selenium with Python, Selenium with Java, Selenium with C Sharp, Selenium with JavaScript. So many, mobile testing. There are a lot of, frameworks or tools are available in the Selenium, so you can use. Right, just give me 1 second. Let me grab one glass of water. Just one. I'm back. Okay. So testing. So that is called the integration testing, right? Now let us understand the continuous integration. You have seen very commonly used symbol for DevOps, which is it is something like this infinite symbol, right? So here you have seen dev, and here you have seen ops, right? So that is DevOps. So in the DevOps, this infinite symbol indicates continuous. Continuous means once this is done, then again next process will be started. In DevOps, basically in a day, you are doing multiple implementation because it's a microservice implementation. So I'm actually, when if you go to the Google, right, and if you search that Amazon uh, DevOps release in a day, means you will be surprised to see that these many times per day, means almost every 1.6 seconds, they are doing the implementation or deployment. How it is possible? That is possible because of this DevOps process, because this is an automation process, right? So until unless you have the automation, see, um, if you blink your eyes, right, that is 1 second is over and they have done one deployment. So that cannot be done with the human intervention, no manual process. Everything is automation. So DevOps is a automation process, and in a day, many times, okay, in a day, many times we are doing the in a day, okay. So before that, there was a agile process, which was having a sprint, right, within 2 weeks, 3 weeks, 4 weeks time. But it is in a day many times because the changes are very small because we are managing the microservices, right? Now, come back to this. So this particular part, this is called continuous integration, CIE. Okay, continuous integration. So what is continuous integration? Developer pushing the code, automatically build, automatically Docker image created, automatically testing is done, automatically a feedback goes back to the developer, right? And developer says, oh, that change is getting failed. Let me modify that change. Again, he will push the code, automatically build, automatically tested, automatically Docker image get created, automatically tested, automatically feedback. Again, there is an error. So again, he is fixing. So this process is continuous. So this is called continuous integration, or in the CI/CD pipeline, when you see CI, so this is CI. And this portion, right, this portion, dev. See here, you see there is no much role of the operation team. It's mostly the development team, they are doing this work. So this is basically your continuous integration. That's why we call it dev, because mostly development related teams, they are basically getting involved in this CI. Now, once consider everything is going fine. So Selenium did the testing is successful. Next, your operation team comes into the picture. So here, the operation team comes into the picture, and they are saying, you are making everything automate, right? For example, if you are saying that my my application, right, that is getting built automatically, Docker image automatically, why don't you make the infrastructure also automatic? Okay. So for example, you need to install some application, you want to create some user, you want to delete some user, etc. Then go with the automation. So there are different automation tools are available, right? And these tools are called the infrastructure as a code tool. So there are many tools are available: Ansible, Puppet, Chef, Terraform, right? So these all are the infrastructure as a code tool. What these tools are doing, they are managing the configuration, right? So they are managing the configuration by using script. So that is why it is called infrastructure as a code, right? Now so this is infrastructure as a code. So that is your Ansible. So uh, here I have mentioned Ansible, but that can be replaced with the other configuration management tool. Now next is the means once your code is deployed, it will be deployed in the form of container, and it is orchestrated by the Kubernetes. So what is Kubernetes? Kubernetes is container orchestration tool. So what is container orchestration tool? For example, you are creating the containers to deploy your application, but if your container is down, if your container is terminated, in that case, Kubernetes is the one who is orchestrating the container, who is deciding that what is the desired state, what is the current state of your container. Okay, so Kubernetes is using a term which is called pod. Let me open one diagram. So Kubernetes. Okay. So Kubernetes works on a cluster. So this is your cluster. In a cluster, you are having your master node. Okay. So this is your master node. What is the master node? If any request come to your Kubernetes environment, that will come through master node. Okay. So the master node is the one who is basically deciding how the containers are to be created. In Kubernetes, we call it pod. Okay, we call it pod. Pod is the basic unit in Kubernetes. Okay, so what is pod? Pod is something which is having a container inside it. If you see this circle, this is a pod, and it is having container inside it. So Kubernetes is always working on a in a very secured environment. Kubernetes is the one which is used by almost all the big companies like Google, Facebook. You can think anyone, right? Google has created this tool. So now you can see the importance. They spent 10 years for its testing. Okay, so it's a Google product, but now it is not managed by the Google, but it was originally developed by the Google. Right. So pod is the basic unit which is running on a pod network. So this is your pod network. So what is pod network? In Kubernetes, first of all, we are using something called cluster. Okay. So what is cluster? Means these three computers, if or three virtual machines, if they are connected to each other and they are on a network, so these are in a cluster. But Kubernetes add one more layer of networking, which is called pod network layer. So this pod network layer is the one. On top of that, these pods are running. Okay. On top of that, these pods are running. So these pods are right the pods which are running on top of this network layer. So these pods are having container inside it, and that container can be your uh, web application, that can be your database application, it can be anything, right? So in this example, if you see, I'm running Nginx application, right? So Nginx is one of the web server like Apache, Tomcat. So this is a single container pod. So there are different pod network solutions or plugins are available like Calico, Flannel, Veeam Network, right? So we can use any one of these, but mostly we use Calico. So in this pod network, right, we are having, for example, this is the CIDR range. What is CIDR range? IP address range. So the IP address range is 192.168.0.0/16. You can give any IP address range. So consider my pod network is created with this CIDR range, right? So it means if if any pod get created on top of this pod network, it will have the IP address between this range. So if you see, this is the IP address 192.168.0.12. Yeah. So this is within this CIDR range. This is multi-container. A pod can have more than one container inside it, which is called the multi-container pod. Right. So there are multiple containers inside it. So it is also having the IP address range within the IP address within this range. Okay. Let me show you how to create a pod quickly. There are multiple ways actually. You can create a script, you can create a command. So let me just show you that. I think I'm connected to one of my Kubernetes cluster. So this is my Kubernetes cluster. If I run a command kubectl get nodes, so you can see that I have three nodes here, right? One is my master node and two are my worker nodes. Now, if you want to create a pod, first let us see is there any pod running kubectl get pods. So you can see there is no pod. So I can create a pod quickly kubectl and run pod one with the image Nginx, right? So my pod is created. So you can see kubectl and get pods with -OY. It means my pod get created. This is the IP address because I have used the same range. So this is a dynamic IP address which will be assigned. So if I delete this pod and if I create a new pod, then that will have a new IP address within the same range. So 192.168.59.235, this is the IP address, and it is running on worker node 1. So you can see I have 3 nodes: master node, worker node 1, worker node 2. So it is running on worker node 1. Right. So if I say curl command, curl, and this IP address, I will get my Nginx application. Right. So you can see I'm able to access the Nginx application. Right. So my pod is running, right? My pod is running with the my Nginx application, right? So this is how we create the pod, right? So there is one more concept which is called config map and secrets. So let us try to understand that concept, config map and the secrets. So config map is, as the name suggests, it is a configuration mapping. Okay, so what is configuration mapping means? For example, if you are having some configuration file, like most of the applications, they keep their application configuration into the configuration file. So if you are using, say an example, Java based project, so application properties, right, web.xml, right, like that, there are many application properties, like where you keep your connection string, which is connecting to the database. So these are the configuration files. With the help of the configuration map in Kubernetes, we can uh, we can have those files into a centralized location. So that is called the config map. The problem in the config map, or not a problem, or the main use case, I would say, of the config map is that when you are having non-critical or non-sensitive data. So say an example, if you are having something which is uh, a string which anyone can see it, plain text, then you are using the configuration mapping. But if you are using something which is confidential data, then you don't go with the config map. You go with the secrets. Okay, so let me just create a secret. Okay, and I will show you. So you guys can go to this website, devopsworld.co.in. Okay, and here I have my scripts. Okay, so if you go here under DevOps, Kubernetes. So here you can see so this is my Kubernetes means notes, which I just kept it for my students. We have different, certifications in Kubernetes, like certified Kubernetes administrator, certified Kubernetes uh, application developer, certified Kubernetes security engineer. Okay. So I'm going to secrets, right? So secret is basically used to store the confidential data. So confidential means what? Confidential means the data should not be visible to others, right? That is the meaning of the confidential. So there are different algorithms are basically used, which are called the base 6. Actually, secret uses one encoding algorithm, which is called base 64 algorithm, to encode the uh, data which is in the secret, right? So it is a key value pair, but it will not be visible by default. So let me just show you one example. I'm creating this file, say username.txt file. In this file, what I am having, this username.txt, right? So it is having admin inside it, right? You can see here admin. Same way, I want to create one more password.txt file. So in this password.txt file, I'm storing this string password, something like this. You can store any data, but I'm just storing this. Now this is a plain text file. When I read this file, it is showing me admin. If I read this file, it will show password. I want to encrypt this data. To encrypt this data, we need to use secret. Not encrypt actually, uh, encode. Okay, we are doing the encoding. So by default, we are using the base 64 algorithm to encode this data. There are other ways also. You can use the SSL certificate, you can TLS certificate, you can use the uh, you know Docker registry. So there are many ways, but we are going to see here in the base 64 algorithm. Now what I'm going to do, I'm going to create a secret, right? So secret type we need to mention. It's a generic or opaque, we call it. So kubectl create secret. Type of the secret is generic. This is the name of the secret. I'm saying nginx secret volume. From file username.txt and from file password.txt. So what it will be doing, from file username.txt, it will take this file and encode this data, and it will take this password.txt and encode the data. So let us run this command. So the secret get created. Let us see whether it is created or not. So if I say kubectl get secrets, so here you can see there is a secret nginx secret volume get created. It is of type opaque, which is generic type, and it is holding two data. So one data is from username.txt and other data is from the password.txt file. So let us see what is the data inside this secret. So for that, you can run this command kubectl and describe secret and the secret name. So the secret name is this one. So here you can see password username.txt, password.txt, but data is not visible. Why data is not visible? Because it's a secret. Okay. So, so this data is not visible because it's a secret, but I want to use this data. Okay. So say an example, you want to use this data to to your pod. Pod is the one where the application is running. So that application needs that username or password. So I want to attach this data, not the encoded data, but the decoded data by using secrets. So when you attach, so your pod automatically decode this data into the plain text. So let us see this. So if I say I'll create a pod, okay. So we can create the pod by using a script also. So here you can see API version v1. I'm creating a pod. This is the name of the pod, right? This is the specification. I'm creating a container, nginx container. We will be using volume concept. Okay, so volume is actually to store the data on the pod. Okay, inside the pod, if you want to use some data. So Kubernetes volumes are very advanced as compared to the Docker volume. Okay, and Kubernetes volume uses its own volume concept instead of the Docker volume concept. Okay, it is pod is nothing. Pod is having a container, Docker container inside it, right? And the volume, Kubernetes says, I will not use Docker volume. I will use my own volume concept. So here you can see the volume. I'm saying volume. It will use this secret. It will take this secret data. Okay, so we have two data, username.txt and password.txt. Now this data I want to mount. Where I want to mount? I want to mount on my test volume. Right? This is the mount path. Within the pod, this will be the path where my username.txt and password.txt files will be stored. Okay, it will be decoded and it will be stored in the form of file. Why file? Because I'm using volume concept and it will be read only. So let us run this pod definition. Right, so let me copy it again. I will go here. I will create pod.yaml file. Let me remove this. So if I say kubectl get pods, let me remove this pod. Kubectl delete pod1. Let me create a new pod from the pod.yaml file. So I will say kubectl create -f pod.yaml. Okay. So pod get created. Right. So now if I say kubectl get pods, so you can see there is a pod get created. Let us describe this pod. I say kubectl and describe pod and the pod name. Right. So this is the pod name. Now here you can see volume, test volume. Test volume is the volume which I have mentioned here. See test volume, and which is referring to this secret. So if I go here, so you can see it is referring to a secret. A volume is populated by secret. Which secret? This is the secret name, right? And this is the volume mount. Means within the pod, the files will be created under this particular directory, etc confidential directory. Right. So let us do one thing. Let us go inside this pod. This is my pod name. Let me go inside the pod. Right. I'm inside the pod at this moment. See that prompt get changed. Right. So that path was cd/etc confidential. It is not necessary you need to create this path. You can create any path. Okay. So I'm inside that folder. Let us see ls. So you can see there is a username.txt and password.txt. How it came here? Because in the volume I have mentioned, take the data from the secret and populate or mount it at this place. So now my data is basically at this path. If I read this data, see it is having admin, right? If I read password, so see it is having the password, right? So right, this is how we are basically storing the data inside the secret, and with the secret we are basically decoding the data inside a pod. Let us go to our slides. So I believe this concept is clear. Okay, so here Kubernetes I was talking. So this is a part of the, okay, so this is called the CD process, continuous. So this is called continuous delivery, means after this testing. So this is called continuous continuous delivery, or we call it continuous deployment. What is that is called CD. Okay, so after this testing, where the operation team is basically working, that is called the continuous deployment. So in continuous deployment, mostly you are working with the operation team. So you as a DevOps engineer, you are working with the development team, CI team, as well as the operation team or the other teams, whichever is required. Now, what is continuous delivery? So continuous delivery is something where code is ready, okay, code is tested, everything is done. But before pushing the code into the production, there is some manual interventions is required. Means, for example, if you're if it is your manager, maybe client, maybe account delivery manager, so it can be anyone, right, who is basically approving the change into the production. So that is called continuous delivery. So in the continuous delivery, it's a DevOps process. Everything is end to end. It is automate, but only pushing the code into the production needs some manual approval. So that is called continuous delivery. So now you are talking to that person or that approver that how do you approve this? So they are approving on the basis of some conditions. For example, they are checking with the UAT team, they are checking with the testing team, that team, and after that, everyone says, yeah, it is passed. Then he is saying, okay, go ahead and deploy this solution. But if you say, we will make this process automatic, the way you are checking with the others, we will make this process automatic. Then it is a then it is called continuous deployment. Okay. So in the continuous deployment, the manual intervention is converted into the manual intervention is basically converted into the automation. So it means now approval is not manual, approval is automatic. So this is called continuous deployment. So the CD, okay, CI/CD deployment we call it. Now these CI/CD deployment or CI/CD pipeline actually we call it. So CI/CD pipeline is this CI/CD pipeline. It is to be done by some CI/CD pipeline tool. There are many tools are available. So if you see here, this is Jenkins. Okay, so Jenkins is a CI/CD pipeline tool. Okay, Jenkins is a CI/CD pipeline tool. So this is the tool which is basically used for CI/CD pipeline. So it means whatever I have explained to you, if you want to make it automatic, so you are using Jenkins. There are many other tools are available. TeamCity is there. There is a GitLab, right? Even though GitHub also you can create the CI/CD pipeline. So this is how the CI/CD pipeline works, right? So I hope there may be some questions. Is pod are kind of virtual machine? No, pods are kind of a which no pods are not virtual machine. It looks like, but it is not. Yeah. Okay. So guys, there is one feedback link which Kritika has shared. So it will be very helpful for me. It will be very helpful for us to know that how this webinar is basically going on. So just spend just 1 minute only. So now let me go back to the PowerPoint. So this is Kubernetes. So what is Kubernetes? This is the logo of Kubernetes. So your applications are running as a container, right? And this application is ultimately managed by the Kubernetes on some worker node. Worker node means it's a node where your pod are basically running, your containers are running in the form of pods. So Kubernetes, the short form of Kubernetes is K8S. See, it is totally 10 letters word starting with K, ending with S, and total number of letters in between is okay. So K8S. This is an open source system for automating deployment, scaling, management of the containerization application. So if there is no Kubernetes, what will happen? Then, for example, your application is running as a container and you need to manage that container. Means if container is down, your client is using that application which is running on a container. If container is down, then it will be a problem, right? Because client is supposed to access that application, and if that container is down, your application is down. So Kubernetes is the one which automatically bring up this application if it is down. Okay, because it is a container. So there is a concept which is called the replication replication controller, replica set deployment, right? There are many concepts are in the Kubernetes. So with the help of that, what we can do, we can we can monitor that whether a particular application is up and running or not. Now, if you are running an application which is a very simple hello world type of application, you can use Kubernetes if your application is running as a container. If your application is a very you know very big application like enterprise level of application, there also you can use Kubernetes. You can install it on your on premises, you can install it on a hybrid cloud, you can install it on a public cloud, you can install wherever you want, wherever you are having the infrastructure, like on the cloud based. If you are using AWS, EKS is the AWS Kubernetes service. In Azure, it is AKS, Azure Kubernetes Service. In Google Cloud Platform, it is GKE, Google Kubernetes Engine. This is the architecture. Here you can see control plane or master node component. Here you can see the worker node component. So API server is the one who is basically uh, front end on the master node. Every request will come through the master node only. And master node is having API server and etcd or etcd server. So this is the database. Database means it stores the data in the key value pair. Your entire cluster information is in the etcd. Scheduler, it will decide that where a pod is to be created, whether it will be created on worker node 1. Worker nodes are the nodes where the pods will be created. So it will be deciding where a pod will be created on worker node 1, worker node 2. And controller manager, it manages the desired state of your Kubernetes resources. Like, for example, you are saying, I need to run 3 pods all the time, similar pod, replicated pod. Then it's a controller manager duty. On the worker node side, we have kubelet. So kubelet is the one, you can say this is the agent on this worker node. What it will be doing? Whatever the pod specification it received from the API server, it is going to run that particular container with that specification. Kubelet kubeproxy is the one which is managing the network policies which are running on the Kubernetes cluster on that particular worker node. And the next one is the container runtime. So container runtime is nothing, but this is the Docker which you have installed. Okay, so this secret we have discussed. So there are many use cases for the Kubernetes secrets or Kubernetes security, right? So for example, Docker image, it is to be secured, which is for that we are using image security. In Kubernetes, we are having a concept of role-based access. Okay, so what is role-based access control? So you are creating users with with some keys, which is the private and public key. You create the certificate for that and give the permission accordingly. So this is called authentication and the authorization. Network security. Network security is basically you want to utilize your network policies. So for example, how one pod can communicate with another pod. So how communication happen, that comes with the network security. We can use some TLS encryption. We can secure our application and API server communication by securing our cluster components. Okay, so port security, there are means, for example, if you are logged as a user and that user is a Linux user, and that user should not have a permission to access a file in a pod, that also you can do with the pod security context or pod security policies, secrets, network policies, and you need to always do a regular update on your Kubernetes cluster, right? So there is a metrics concept. What is metric concept? It will basically checking that how many pods are running, how many worker nodes are running in this cluster, and how much CPU or memory utilizations they are memory or CPU utilization they are using. So that is called metrics. This metrics is used for the horizontal pod autoscaling. Means, for example, your application says that if the CPU utilization is more than 70%, then create a new pod. This is called horizontal pod autoscaling. If the CPU utilization is less than 10%, then delete the pod. Okay, so that is called horizontal autoscaling. For that, we define some target metrics. Right. So these are some use cases like, as I mentioned, in the DevOps process, which is widely used by the industry now. Docker and Kubernetes, they are playing very important role because most of the Google applications, these are running as a container and managed by the Kubernetes. So for example, Spotify, this is a very popular music streaming service. It is also using the DevOps culture, and it is using Kubernetes for managing the containers. So they are having a lot of microservices, which are very complex microservices, which needs a regular deployment and regular scaling also. So they are using the Kubernetes for that to achieve a auto deployment, auto scaling, right? And so that millions of users, those who are using that Spotify application, they can make a use of of this application. Okay, so Kubernetes is the main focus point for for this Spotify. Okay, I think that's it for the training point of view. Let me see if there is, if you guys have any question, you can ask that question. If anyone has any question, you can ask. Okay, I don't see any question. Okay, cool. I believe everyone has just spent a bit time to this survey. All right, so Kritika, you there?
Hi, yes, sir.
Okay, one person has raised the hand, Abdul Sheikh. So I don't know whether they can speak or Abdul, you can just write your question on the chat window,
Abdul, you can unmute yourself and speak.
or you can unmute. Yeah.
Yeah, I just have one question. How do we manage the DevOps environment itself? Say, do we have a single environment, a
No.
production environment, or different environments?
Yeah. So DevOps is basically this diagram which I have shown you, right? So this environment you create, like you are creating a traditional environment, like you are having separate build server, you are having separate testing server, you are having separate server where your applications are getting deployed, your containers. So these are collection of machines, means it's a cluster level, and you are using these environment, like if it is a staging, for example, this environment, replicated environment you are creating for the staging, for testing, for UAT. So when you think that everything is fine, then you are creating the similar environment for the production.
Yeah, I mean, there are environments for managing the applications, right? So dev,
Right.
sandbox, test, and product, UAT, pre-prod, and production. For the DevOps,
Similar.
also, say for example, I'm doing some, I'm a new to DevOps. Okay, I'm trying to test something. Okay, in my own dev environment, right? So to
Mhm.
see whether everything, whatever is there in dev environments, right? I would like to test first before actually, running those my DevOps scripts into a real production environment.
Correct. So for that, we will have our dev environment. We are having, this environment which I have mentioned here. So this will be you are creating in different environments in your, like you are having testing environment, right? So because this, before pushing it into the production, you want to make sure that everything is working as per the expectation or not. So you are creating different clusters. One, the cluster for UAT, the cluster for the test, the cluster for your production. So actually we are having different branches. The development team, they create, and so if it is staging, so staging will be started. If it is production, the production automation process starts when we fire that from a master branch.
Okay. In the diagram, what is the purpose of Ansible?
Ansible is a infrastructure tool. Means, for example, you want to install Java on a particular machine. If it is a one machine, it is easy. If it is 10 machine, it is easy. But if it is 500 machine, right? So in that case, you want to automate this process. Then we need the configuration management tools. So the configuration management tool is like Ansible, Chef, Terraform, right? So these are the configuration management tool.
Oh, thank you.
Good. Great questions. Okay, so I see there is someone else also has raised the hand. Gopinath, you can unmute yourself.
A wonderful presentation and webinar. And the question is the was
Uh, Gopinath, sorry, I'm not able to hear you properly. Yes, PPT will be shared, right? Recording
no,
will be
no,
shared, but what is the next question?
no. I said first of all, thanks for the wonderful presentation. So the question is,
Yeah.
the ports and nodes are for to isolate the microservices, or it's a failover kind of stuff. I mean, one port is down, then the other port will start serving the request.
No, no, that is pods are basically a deployment unit. Like in Docker, we are having the container as a deployment unit. In Kubernetes, we are having the pods as the deployment unit. But if you want something, if one pod is down, another pod can take over. So these things are also possible in Kubernetes because Kubernetes is having a lot of features, and these are the very commonly used use cases we are having, right? So like replication, load balancing. But if we talk about a single pod, it is basically running your application. If this pod is terminated, it will not be uh, taken care by anyone else. So we need to perform different operations like replication controller, deployment, replica set. So that we have not discussed actually here. So like horizontal pod auto scaling, I have mentioned. So horizontal pod auto scaling, if CPU utilization is more than 70%, I want a new pod is to be created. So that's a separate concept. But pod itself, it's not a automatically, it's kind of a the whatever the task it is doing, if it is down, it will be given to the other pod. It will not happen by default.
Okay. Thank you very much.
Yeah, cool. Yeah. All right. So, Sheet Jilwa, you can unmute yourself and you can ask the question.
Yeah, hi Raman. So I
Yeah.
had one question. I would just like to add on your last answer. So just wanted to ask that you mentioned about the replication. So do you mean
Mhm.
that we need to configure? By that, do you mean that let's say all I think that file that you had shown us that to create a container, probably a YML file. So do we need to
Mhm.
put this replication configuration over there, or it is a separate process?
Yeah. So replication is a separate. You see here replication controller, right? In the replication controller, you will see
Mm-hmm.
here there is a pod definition. So we need to specify a pod definition here. We need to specify a replication controller and how many replicas we want to create. So it will maintain this desired state. If it is three, it means three ports are similar port are always up and running.
Okay. All right, and let's say that if any one of them goes down, then the other one will take care of it, or
Correct.
at a time, uh, like let's say out of three, one has gone down, then another pod will be automatically created. Is it so?
Correct. Correct.
Okay. Okay, all right. And one more question I had around, as you had mentioned that you can also use like AWS's this Kubernetes infrastructure or Azure's, right? So, like, how does the entire structure looks like? Like, let's say that if I'm using AWS's infrastructure, then do we actually use EC2 machines for the actual hosting or not? Like,
No,
I'm
no,
not having much
no,
clarity
no.
around that.
No. EC2, when you're creating that, that is not the, you're not fully utilizing the AWS. You need to go with the EKS, Elastic Kubernetes Amazon Service. Here, the entire infrastructure will be created on the AWS. Means your master node, worker node, everything will be managed by the AWS by using this service.
Mhm. So by a
So
node, like, do we mean any machine or any like remote machine or what exactly?
virtual machine, you can think node as a virtual machine.
Okay, so then can't we like consider EC2 as well as a virtual machine?
You can take that. That's what I'm saying. But that will not utilize the AWS services. AWS services, if like you want to use S3 bucket, you want to use EBS volume, load
Mhm.
balancer. So then you need to create something Elastic Kubernetes service.
Okay. So you mean that like let's say if I want to utilize all those AWS services, like
Mhm.
ECS also. So in that case, I need to use this EKS, which is
Correct.
AWS's managed service. But other
Correct.
than okay, so in other case, if I'm not utilizing that, then how
Then
like what exactly is the advantage that I need to use this
no.
AWS's infrastructure?
So here basically what happens here, all the systems, you need not to create the EC2 instance. EKS will create on behalf of you. EKS will manage the
Okay,
auto scaling. EKS will perform. You need not to create EC2 instance. You need not to install Kubernetes. So everything will be done by this EKS.
all right, understood. Okay, thank you so much.
Yeah, good questions. All right,
Sir,
guys.
I
So I
can
think
see some questions in the chat window. Can you please answer those as well?
one second. We have CI/CD implemented in our project, which automatically upload the app to App Store or Play Store. So how they can do with the Kubernetes? So your application will be Bhumi, and that is your question answer. So the your application, it is using the similar kind of concept, the one which I have explained here. So your application is running as a container and automatically it is uploaded, means that container, if it is they are using the containerization technique, then it will be deployed to the your Play Store. So same process, means here I have given my Java based project, but it can be any type of project. So you need to see which application, what is the programming language they are using, what is the build automation tool, etc. All right, so I think we are done. Thank you guys for joining this session. Yeah, I think we can wind up, Kritika.
Yes, sir. Thank you for your time.
Yeah, thank you. Thank you, everyone. Bye bye.